So someone asks you how much energy is required to change 10 grams of ice at negative 15 degrees Celsius to a gas at 120 degrees Celsius. This may be your teacher, your mother, or just a curious person you meet along the street. Well, the calculation is a little bit more tricky than you would think. What we need to do is consider each of the changes that the sample of water is going to go through, taking it from negative 15 degrees Celsius all the way up to 120 degrees Celsius. The first thing we want to do is identify the changes that the water is going to go through. So obviously at negative 15 degrees Celsius, we're going to have water in the solid state, and up at 120 degrees, we're going to have water in the gaseous state. So there's going to be two changes of state that will occur. One will happen at the melting point, 0 degrees. The other one will happen at the boiling point, 100 degrees. So in order to melt the water, we're going to have to add energy to get it from negative 15 up to 0. So over the first part of the time that we're adding the energy, the temperature is going to go up to 0. Now, as we learned before from doing the lab on this, once we get to the 0 degrees and we're going to change from solid to liquid, the temperature is going to remain constant. So we'll go ahead and add in a line for that addition of energy that's going to melt the ice. Once the ice is melted, now we're going to, it's in liquid state, we need to get it up to 100 degrees so that we can boil the water. So let's go ahead and do that line. Up to about there. Okay. And the next step that we're going to need to do now is to boil that water. So we're at 100 degrees, and we're going to boil that. And again, that would be a plateau part there. This plateau is going to be longer than the plateau for melting it, so it would be an interesting thing for you to think about why that plateau or that time would take longer. And then finally, we will raise the temperature up to the 120 degrees that the problem asks for. Okay. So you see 5 different parts to this graph. Each part is going to require a different calculation. So I'm going to go ahead and label those. So we'll have this energy added here, which will be number 1. The energy here, number 2. The energy in this part, number 3. Energy in this part, number 4. And then the final amount of energy that we'll add, I should move this over a little bit here. So number 4 here. And the final energy we need to calculate is number 5. Okay. Now you'll notice, to organize this a little bit, there's 2 parts that are plateaus and there are 2 parts where the temperature's changing. So we're going to deal with those a little bit in a similar fashion. So the diagonal parts where there's a temperature change, so this would be for parts 1, 3, and 5. We're going to use a formula that allows us to figure out that energy that's based on the amount of water that we're heating and what's called the specific heat of the water. So the energy that we have to add is going to be called Q. Right? So this is the heat added to the water. Is going to be equal to the mass of the water that we're heating times the change in temperature times what's called the specific heat. And the specific heat is going to be different for each substance, and it will be different for each state of matter for the substance. it will tell you how much energy you need to add in order to change the temperature of 1 gram of that substance 1 degree Celsius. So if we take change number 1, right, so this is the heating up of the solid water, so Q1 would be equal to, all right, the mass of the water, which according to the problem was 10 grams. The change in temperature of the water, we went from negative 15 to 0, so we're going to do final minus the initial. So 0 minus negative 15 would be 15 degrees. The specific heat for solid water is negative 2.09 joules per gram degrees Celsius. So if we multiply all this out, we get roughly 300 joules of energy that are required to melt the ice. And we can cancel our units out just to make sure that they work. So we get an energy unit for our answer. All right, so that's just that first part of the graph. Now you can go through and do the same thing for 3 and 4. For 3, let's go back up here to the graph. For part 3, we are in the liquid state. So we're going to need to find the specific heat of liquid water, like we had done here as a solid. And for number 5, for energy change 5, we're going to have to find the specific heat of the gaseous state of water. Okay, so you can look those up on the internet to find the values for water. Now let's take a look at 2 and 4. And let's use a different color here. So 2 and 4. So 2 represents the melting of ice, which also we call the fusion. And so there we have the energy that's going to be added. So Q2 is going to be equal to the mass. Again, the amount of energy we put in is going to depend on how much ice we're trying to melt, how much solid we're trying to melt. So we've got mass times, and in this case, instead of a specific heat and change of temperature, we have what's called the heat of fusion. Okay, sorry, one S in fusion. Right. And again, this value is going to be specific for a given substance. So for the water, we have a mass of 10 grams, and the heat of fusion is 334. Let's be consistent here. So 10 grams times 334 joules per gram. Now notice there's not the degrees Celsius part here because there's no temperature in the formula there. The temperature is constant during this part. And so that would be a heat being added then of 3,340 roughly joules. And so you can see that's a significantly larger amount of joules that have to be added compared to the amount that were added to heat it up. So that change of state requires a lot more energy. 4, you can do a similar kind of thing. In 4, you're changing it from a liquid to a gas, and that's the heat of vaporization. So again, you'd have to look up the heat of vaporization for water to put that into that formula. So go ahead and do that calculation. Check it out, and then we'll verify that in class to see if you got the correct answer. So again, you need to go back through and determine the heat of fusion, or the energy for number 3, number 4, and number 5. Calculate that, get a total amount, so add all those things together, bring that into class, and we'll discuss that.